All right, good morning, everyone. Hello, everyone. Today we'll talk about the exercise 2.4 polynomials. In exercise 2.4, we'll have a look on factor theorem. After this, we'll have a look on factorization. Even the chapter, this exercise 2.4 and 2.5 is very important from the examination point of view because in examination, they may ask whether the given polynomial is factor or not. So just have a look on the first question. Determine which of the following polynomial has x plus 1 as a factor. So we have a look in factor theorem that x plus 1, if it is given x plus 1 as we are dividing the polynomial by x plus 1, we can apply the factor theorem here. That is, we can substitute the value of x as minus 1. If we are substituting the value of x as minus 1 in the first question, then it will be minus 1 cube plus minus 1 square minus 1 and plus 1. That becomes 0. So in this case, if it is becomes 0, that will be a factor of the given polynomial. Have a look. Px is x cube plus x square plus x minus plus 1. If we are substituting x is equals to minus 1, that is minus 1 cube plus minus 1 square plus minus 1 plus 1. That is minus 1 plus 1 minus 1 plus 1. This minus 1 plus 1 minus 1 plus 1 will get cancelled, and that will be the 0 of that polynomial. So hence, x plus 1 is a factor of the given polynomial. Now we have a second question here. X raised to power 4 plus x cube plus x square plus x plus 1. X raised to power 4 plus x cube plus x square plus x plus 1. We need to find whether this is a factor or not. So I'm getting the answers from you that it is not a factor. Just let's check. If you are substituting the value of x as minus 1 in the given polynomial, that is minus 1 raised to power 4 plus minus 1 raised to power 3 plus minus 1 square plus minus 1 plus 1. That is 1 minus 1, 1 minus 1 and 1. This 1 minus 1, 1 minus 1 will get cancelled and we left with 1 only. This is not the factor of this polynomial. Hence, by using factor theorem, x plus 1 is not the factor of x raised to power 4 plus x cube plus x square plus x plus 1. Now we have the third question in front of us. Third question says x raised to power 4 plus 3x cube plus 3x square plus x plus 1. Substitute the value and get let me know whether this is a factor or not. Okay, I got the answer from Aditya. Third, it is not a factor. Let's check. We'll substitute the value as minus 1. Minus 1 raised to power 4 is 1. Minus 1 cube is minus 1. That is minus 3. Then plus 3 minus 3 plus 3 will get cancelled. Minus 1 plus 1 will get cancelled. We're left with minus 1. This is not the factor of this polynomial. So let's check in the solution as well. Yes, minus 1 raised to power 4 plus 3 minus 1 raised to power 3 plus 3 minus 1 raised to power 2 plus minus 1 and plus 1. So plus 1 minus 1 plus 3 minus 3 will get cancelled, left with 1 only. That is the constant part. So 1 is not equal to 0. Hence, by using factor theorem, this is not the factor of x raised to power 4 plus 3x cube plus 3x square plus x plus 1. Now we move on to question number 4. Now question number 4 says x cube plus x square plus minus 2 plus root 2 x and plus root 2. X cube, that is minus 1 cube minus 1, minus 1 square minus minus 1 square, that is minus 1, minus 1 minus, and this minus 2 minus root 2 and into x, that is become, if we'll multiply it by minus 1, it will become plus 2 plus root 2 and plus root 2. So it will be 2 root 2 instead of 0. So it is not a factor of this polynomial. Let's say. Yes. When I substitute this x is equals to minus 1, this is minus 1 cube plus minus minus 1 square minus 2 root 2 into minus 1 plus root 2. So when this minus 1 multiplied inside the bracket, this minus 1 multiplied inside the bracket, that minus outside the bracket will become positive. So minus 1 cube will be minus 1, minus minus 1 square will be minus 1 itself. This will be plus 2 plus root 2 and plus root 2. So we minus 1 will be minus 2. Minus 2 and plus 2 will get cancelled. We're left with root 2 plus root 2, that is 2 root 2, which is not equals to 0. So it is not the factor of this polynomial using the factor theorem. Now let's move on to question number 2. Using the factor theorem to determine whether gx is a factor of px in each of the following cases. So we have first question in front of us, 2x cubed plus x square minus 2x minus 1, and gx is given x plus 1. 2x cubed plus x square minus 2x minus 1, and gx is given x plus 1. So if gx is given x plus 1, the value of x will be minus 1. Value of x is minus 1. We'll substitute the value of x as minus 1 in px. When you substitute the value of x as minus 1 in px, this will give you p of minus 1 as 2 into minus 1 square, 2 into minus 1 cube plus minus 1 square minus 2 minus 1 and minus 1 outside as constant. Now minus 1 cube is minus 1, 2 into minus 1 will give you minus 2, minus 1 square is positive 1, 2 minus 2 into minus 1 will be plus 2 and minus 1. So we have the positive 2 plus 1 3 and negative minus 2 minus 1 3. 3 minus 3 will give you 0. So this is not, this is the, if remainder is 0, then gx is factor of px. That is, using factor theorem, gx is equals to x plus 1 is factor of 2x cubed plus x square minus 2x minus 1. This is what the factor theorem is. Now, second part of question number 2. X cubed plus 3x square plus 3x plus 1 and x plus 2. X cubed plus 3x square plus 3x plus 1 and x plus 2. If x plus 2, x is equals to minus 2. Let me know whether it is a 0 or not. So we'll substitute x is equals to minus 2 in the given polynomial. Minus 2 cube will be minus 8. Then 3 of x square, that is 3 of minus 2 square. Minus 2 square 4. 4 3s are 12. 3 of minus 2 minus 6 and plus 1. This will be 6 and 8 14. 12 plus 3 13. 13 minus 14 will give you minus 1. So it is not the factor of given polynomial. Now the third part of the question number 2. X cube minus 4x square plus x plus 1, x minus 3. If x minus 3, x is equals to 3. X is equals to 3 when you substitute x is equals to 3 in the given polynomial. What will be the answer? So if I substitute x is equals to minus, x is equals to plus 3 in the given polynomial, it will be 3 cube minus 4 into 3 square plus 3 plus 6 plus 3 plus 6. 3 square 9, 9 4s are 36 with negative sign, and 3 cube is 27. So here 3 cube is 27. 4 into 3 square is minus 36 plus 3 and plus 6. This is 36 minus 36. The answer is 0. If it is 0, it is thus gx is equals to x minus 3 is the factor of the given polynomial using factor theorem. Clear? Now, the third question, it is generally asked in 2 marks. Find the value of k if x minus 1 is a factor of px in the given following cases. So in first part, px is equals to x square plus x plus k, and x minus 1 is the given as the factor. If x minus 1 is given in the factor, while we substitute x is equals to 1 in the given polynomial, the polynomial should become 0. So when we substitute x is equals to 1 in the given polynomial, because x minus 1 is the factor given by factor theorem, p of 1 must be is equals to 0. Then p of 1 is equals to 1 square plus 1 plus k is equals to 0. 1 plus 1 is 2. 2 plus k is equals to 0. This gives you k is equals to minus 2. So when you substitute the given, when you substitute the value of x as 1 in the given polynomial, that must be is equals to 0. Well, while equating it with 0, 2 plus k is equals to 0, then k will be minus 2. Now, next part. 2x square plus kx plus root 2. 2x square plus kx plus root 2. While substituting x is equals to 1 in 2x square plus kx plus root 2, we'll get this. P of 1 is equals to 0. There is 2 of 1 square plus k of k into 1 plus root 2 is equals to 0. This will give you 2 plus root 2 plus k is equals to 0. We'll transport this 2 plus root 2 towards right hand side. That will be minus of 2 plus root 2 or minus 2 minus root 2. So minus 2 minus root 2 is the right answer for the given question. So k of minus 2 plus root 2 in the bracket, or k of k is equals to minus 2 minus root 2. While taking minus sign common, we can write it as minus sign bracket 2 plus root 2 as well. Now, the third part of the question. It says kx square minus root 2x plus 1. We need to find the value of k. Kx square minus root 2x plus 1. So by substituting x minus 1 is equals to 0, we'll get x is equals to 1. X is equals to 1, we'll substitute p of 1 is equals to 0. That is k1 square minus root 2 1 plus 1. That is k minus root 2 plus 1 is equals to 0. We'll transport this. Minus root 2 will become plus root 2 and minus 1. So the answer is k is equals to root 2 minus 1. Now the last part of question number 3. Kx square minus 3x plus k. Kx square minus 3x plus k. We'll substitute k is equals to x is equals to 1. So this will give you p of 1 is 0. Kx square, that is k into 1 square, minus 3 into 1 plus k is equals to 0. We'll have k minus 3 plus k is equals to 0. There is 2k is equals to 3 and k is equals to 3 by 2. Yes, you all are correct. You wrote the right answer. The fourth one is k is equals to 3 by 2. Now, factorize the given polynomial. This is quadratic polynomial or quadratic equations. We had seen how to factorize a quadratic polynomial in class 8 also. So we need to factorize 12x square minus 7x plus 1. We need to factorize 12x square minus 7x plus 1. First, we'll multiply first and the last term, that is 12. We need to find the factor of 12 such that the addition or subtraction will become minus 7, whereas the product of the minus 7 will remain as 12. So we'll factorize 7, that is middle term, minus 7x, such that minus 3x and minus 4x. Minus 3x minus 4x will become minus 7 again. And while multiplying minus 3x minus 4x, we'll get 12x square. Minus 3x minus 4x. When we multiply minus 3 and minus 4, this will give you plus 12. So while adding 3x and 4x, we'll get 7x. Again, minus 3x minus 7x will get minus 7x. And when we multiply minus 3x minus 4x, this will give you plus 12. That is the product of first and last term. 12 into 1. So we will get, we can split the middle term. Minus 7x is minus 3x minus 4x, because minus 3 minus 4 will be minus 7. And product of minus 3 minus 4 will be 12. So after taking 3x common from the first two terms, we can take 3x common, that will be 4x minus 1. And we can take minus 1 common, that will be 4x minus 1. Now the factors, we can take 4x minus 1 common from this. Here also we have 4x minus 1 here, and here also we have 4x minus 1. So we can take 4x minus 1 common from this two terms. We're left with 4x minus 1 common and left with 3x from here and minus 1 from here. So 4x minus 1 and 3x minus 1 is the factorized form of the given polynomial. Now, second part is 2x square plus 7x plus 3. 2x square plus 7x plus 3 will multiply the extreme. 2 into 3, 6. We need to split 7x such that the product will 6 and addition will remain 7. So we can write 7x as 6 ones are 6 and 6 plus 1 will give you 7. That is 6x plus x. So we can write the middle term as 7x as 6x plus x. Now this 2x square as it is and 3 also as it is, we can take 2x common from the first two terms. Out of these two terms, we can take 2x common. While taking 2x common, we're left with x plus 3 from here. And in the last two terms, we don't have anything common, so we can take 1 common from this last two terms. While taking 1 common, we're left with x plus 1 here, x plus 3 here, and x plus 3 here also. So while we having x plus 3 common, we can take x plus 3 common from here and left with 2x plus 1. So this is the factorized form for question number 2, that is x plus 3 and 2x plus 1. Now the third part of the same question is for 6x square plus 5x minus 6. 6x square plus 5x minus 6. 6 6 are 36. So we need to split 5x such that the product will remain 36. But it is here point to be note, the first term is positive and last term is negative. If the first term is positive, last term is negative, the factors will be one positive, one negative here. So we can write 9x minus 4x as 5x. We can split in 9x minus 4x such that 9 4s are 36 with negative sign, because 9 positive, 4 negative. 9 4s are 36. 9 into minus 4 will give you minus 36. And while multiplying 6 and minus 6, you will get minus 36. After subtracting 9 minus 4, we will get 5 again. So we have 9x minus 4x is the factorized form of the given question. Now we can take 3x common from the first two terms. While taking 3x common from the first two terms, we'll get 2x plus 1, 2x plus 3 here. While taking 3x common, we'll get 2x plus 3 here. And while taking 2 common from the last two terms, we'll get 2x plus 3 here as well. So we have 2x plus 3 common. Now taking 2x plus 3 common from these two terms, here we have 2x plus 3 and left with 3x from the first term and minus 2 from the last term, that is second term. So we'll get the factorized form is 2x plus 3, 3x minus 2. And the last part, that is fourth part of question, 3x square minus x minus 4. 3x square minus x minus 4. So we can take 3x square and minus 4. 3 4 the 12. So 3 into minus 4 will give you minus 12. Now we need to split this minus x, that is minus 1, such that the product will remain minus 12 and the addition will remain minus 1. Addition or subtraction will remain minus 1. So because first term is positive, second term is negative, we need to take first positive, second negative. That is minus x can be written as minus 4x plus 3x. Minus 4x plus 3x will give you minus 1x. And the product of minus 4 and plus 3 will give you minus 12. So in the first two terms, first term 3x square minus 4x, the first two terms, we can take x common. While taking x common from these two terms, we left with 3x plus 3x minus 4. And the last two terms, there is 3x minus 4. We don't have anything common, so we can take common 1. So we left with 3x minus 4 again. Now we have 3x minus 4 common in both the terms. We can take 3x minus 4 common, left with x plus 1. So this is the factorized form for question number 4 also. Now the most important part is question number 5, that is x cube minus 2x square minus x plus 2. X cube minus 2x square minus x plus 2. This question will be surely in all the examination, whether it is half yearly, whether it is periodic test, whether it is annual examination, this question will be asked in all the examinations. So we need to factorize x cube minus 2x square minus x plus 1. Not exactly this question, but this sort of question. X cube minus 2x square minus x plus 1 we need to factorize. So we need to check it. Yes, Geet, you are correct, but this question can be solved in that method. But if you have a look on the third and second part, you cannot be able to solve in the same way. Okay, x cube minus 2x square minus x plus 2. Just have a look. We need to do the trial and error method here. So just have a look. It is given x cube minus 2x square minus x plus 2. We need to check the last term. The last term is, the constant term is 2. The constant term is 2. We need to find the factors of this 2. These factors are plus 1, plus minus 1, and plus minus 2. There is plus 1 minus 1 and plus 2 minus 2. Factors of 2 are plus 1 minus 1 and plus 2 minus 2, because we can write 2 as minus 1 into minus 2 or 1 into 2, not any other way. So all the factors of minus 2 are minus 1, plus minus 1, and plus minus 2. All the factors of 2 are plus minus 1, plus minus 2. Now we have this factors of plus 1, factors of 2 as plus 1 minus 1 plus 2 minus 2. We need to substitute these possible factors. While substituting p of minus 1, we'll get minus 1 cube, minus 2 of minus 1 square, minus of minus 1, and plus 2. There is minus 1 cube is minus 1, minus 2 is minus 2, minus 1 square is 1, and 1 into minus 2 will minus 2. Minus of minus 1 will give you plus 1 and plus 2 as it is. In the positive sign, we have 2 and 1, that is 3. And in the negative sign, we have minus 1 and minus 2, that is also minus 3. Then 3 minus 3 is 0. So P of minus 1 is 0. Here the P of minus 1 is 0. What does it mean? If P of minus 1 is 0, it means x plus 1 is one of the factor of the given polynomial. If P of minus 1 is 0, it means x plus 1 is the factor of Px. If x plus 1 is the factor, what we need to do further is we need to divide the given polynomial, that is x cube minus 2x square minus x plus 2, using long division method to find out the other factor, because the dividend is equals to divisor into quotient plus remainder. Here we have dividend x cube minus 2x square minus x plus 2, divisor x plus 1, quotient x square minus 3x plus 2, and remainder is 0. While dividing this x cube minus 2x square minus x plus 2 by x plus 1, after 3 steps, we will get remainder is 0. Now the remainder is 0, it means the given polynomial x cube minus 2x square minus x plus 2 is nothing but the product of x plus 1 and x square minus 3x plus 2. It is nothing but the product of this terms. Now, because x square minus 3x plus 2 can be obtained by splitting, we can find out the factor of x square minus 3x plus 2, that is this term, using middle term splitting, because this is quadratic polynomial as we did in the previous question. So while considering this x square minus 3x plus 2, we'll get the factor of x square minus 3x plus 2 as x minus 1 and x minus 2. We get the factors as x minus 1 and x minus 2. We can take x common, x minus 1, we can take minus 2 common, again x minus 1, because we are splitting this minus 3x as minus x minus 2x. We are splitting this minus 3x, this minus 3x as minus x minus 2x. So we'll get the same value. So after taking x common, x minus 1 and minus 2 common, x minus 1, these are the factors, x minus 1, x minus 2. And one factor we have x plus 1 using long division process or by a trial and error. So x cube minus 2x square minus x plus 2 will give you x plus 1, x minus 1, and x minus 2. These are the three factors of the given polynomial. Because the quadratic polynomial have degree 3, it has maximum 3 zeros only. It has maximum 3 zeros only. Minimum could be only 1, but maximum are 3 zeros possible for the given polynomial, and we have three factors here, x plus 1, x minus 1, and x minus 2. These are the factors of polynomial given. Let's move on to the second part of this question. The question given is x cube minus 3x square minus 9x, x cube minus 3x square minus 9x minus 5. The constant part here is 5. We need to find the factors of this 5. The factor of 5 are plus 1 minus 1 and plus 5 minus 5. The factors are plus 1 minus 1 and plus 5 minus 5. So we'll substitute the value as plus 1 minus 1 plus 5 minus 5 in the given question. While substituting p of minus 1, we'll get 0. So we don't need to substitute the further values as we got one of the 0. So p of minus 1 is minus 1 cube, minus 3 of minus 1 square, minus 9 minus 1, and minus 5. So minus 1 cube is minus 1, minus 1 square is plus 1 into minus 3 will give you minus 3 here. Then 9 of minus 1 is plus 9 and minus 5 as it is. 9 positive and 5, 3 and 1 negative. So 1 plus 3, 4, 4 plus 5, 9. This is 9 negative. 9 minus 9 will give you 0. It means p of minus 1 is 0. It represents x plus 1 is the factor of the given polynomial. If x plus 1 is the factor of given polynomial, we need to divide the given polynomial by x plus 1. While dividing the polynomial by x plus 1, we'll get x cube minus 3x square minus 9x minus 5 divided by x plus 1. So first term is x cube here in the division, and first term of divisor is x. That is the first term of quotient will be x cube upon x, that is x square. X square into x cube, x square into 1 will give you x square. By subtracting x cube minus x cube will give you 0. 3x square minus x square, there is minus 3x square minus 4x square will give you minus 4x square. Minus 3x square minus x square will give you minus 4x square here. Minus 9x minus 5 as it is. So minus 9x we are taking out. Now the first term is minus 4x square and here is the first term is x. So next term will be minus 4x. So here we have minus 4x. Now this minus 4x into x will give you minus 4x square. Minus 4x into plus 1 will give you minus 4x. While subtracting, we'll change the sign. So minus 4x plus 4x square will get cancelled. Left with minus 9x and plus 4x. Minus 9x plus 4x will give you minus 5x. And minus 5 as it is. Now minus 5x divided by x will give you minus 5. Minus 5x minus 5. Minus 5 into x minus 5x. Minus 5 into 1 minus 5. While subtracting, will change the sign and remainder will become 0. This is short because we are getting p of minus 1 is 0. The remainder must be equals to 0. If it is not 0, you might have done any mistake in long division process. So x cube minus 3x square minus 9x minus 5 is x plus 1, x square minus 4x plus 5. As dividend is equals dividend is equals to divisor into quotient, and remainder is 0. So while after taking x square minus 4x minus 5, we'll split the middle term. After splitting the middle term, we'll get x minus 5, x plus 1. These are the two factors, and one of the factor is x plus 1. The three factors are x plus 1, x plus 1, and x minus 5. Here the two factors are same, and second factor is x minus 5. So x plus 1, x plus 1, and x minus 5 are the factors of x cube minus 3x square minus 9x minus 5, or the factorized form of x cube minus 3x square minus 9x minus 5 is x plus 1, x plus 1, and x minus 5. Now the third question. We have x cube minus x cube plus 13x square plus 32x plus 20. This is very common question asked in the examination. X cube plus 13x square plus 32x plus 20. We need to split. We need to find the factors of this question. To find out the factors of this question, we need to find the factors of 20 first. It is as the constant part is 20 in this question. So we'll find out the factors of 20. The factors of 20 are plus 1 minus 1, plus 2 minus 2, plus 4 minus 4, plus 5 minus 5, then plus 10 minus 10, and plus 20 minus 20. So we'll find out the factors. We have find out the factors of plus 1 minus 1, plus 2 minus 2, plus 3 minus, plus 4 minus 4, plus 5 minus 5, plus 10 minus 10, plus 20 minus 20. Now we'll substitute the values. We'll do the trial and error. After trial and error, p of 1. If we substitute the value positive, because all terms are positive, this will not if we substitute the positive value of x, that will never become 0. So we are substituting the value negative part. P of minus 1 is 0. After substituting, minus 1 cube is minus 1, minus 1 is square is 1. 1 into 13 will give you plus 13 here. 32 into minus 1 will give you minus 32 and plus 20 as it is. Now this 20 and 13, 33, minus 1 and minus 32, minus 33. 33 positive, 33 negative will cancel, that is become 0. So P of minus 1 is 0, it means x plus 1 is factored using factor theorem. So by factor theorem, x plus 1 is factor of px. Now dividing the given polynomial px by x plus 1, will get the value of quotient. So by dividing the polynomial x by x plus 1, we'll get the quotient as x square plus 12x plus 20. Now this is the quotient. After dividing the polynomial, after 3 steps, we'll get the x square plus 12x plus 20. Now, if it is the polynomial, then the product of x plus 1 and x square plus 12x plus 20 will become x cube plus 13x square plus 32x plus 20. So we'll split x square plus 12x plus 20 by middle term splitting. After middle term splitting, this x into x plus 2 and x 10 into x plus 2, this step will get, because we'll split this 12 such that the product will become 20. So we'll split it as 10x and 2x, that is 2x plus 10x. After this, we'll take x common from the first two terms. After taking x common from these two terms, we'll get x into x plus 2. And in the last two terms, we can take 10 common. While taking 10 common, we'll get 10 into x plus 2. Here we have x plus 2 common in both the terms. So here the x plus 2 common, left with x in the first term and 10 from the last term. That is x plus 10. So these are the two factors of the polynomial after middle term splitting. In one factor we already have, that is x plus 1. So x cube plus 13x cube plus 32x plus 20 is x plus 1, x plus 2, and x plus 10. Very good. Tanisha, Prabgun, Geet, Viraj, Priyanshu. Very good. Now the last part of the question, Ishan was asking, is 2y cube plus y square minus 2y minus 1. We need to split. So we need to do the factorization of this question. That is 2y cube plus y square minus 2y minus 1. Plus 1 and minus 1 are the factors of this minus 1. So we'll substitute p of 1. P of 1 is equals to 0. P of 1 is 0. Then y minus 1 will be the factor of the given polynomial. If y minus 1 is the factor of given polynomial, py is equal to y minus 1. While dividing dividing the given polynomial by y minus 1, we'll get quotient as 2y square plus 3y plus 1. So 2y square plus 3y plus 1 is the quotient. We'll do the middle term splitting for this 2y square plus 3y plus 1. After completing the middle term splitting, we'll get 2y common from first two terms. That is y plus 1 is the remaining factor after taking 2y, and plus 1 common from the last two terms, that is y plus 1 here as well. So we can take y plus 1 common from here and here. That is y plus 1 common remains with 2y from the first term and plus 1 from the last term, that is 2y plus 1. So these are the two factors, and one factor we already have as y minus 1. These are the three factors of the polynomial, that is 2y cube plus y square minus 2y plus 1 can be represented as y minus 1, y plus 1, 2y plus 1 in the factorized form. That's all for 2.4 exercise. And the last two questions, that is the factorization, middle term splitting, and the factorization of cubic polynomial is very important from the examination point of view. So just be prepared for these questions. This will surely help you out in the examination. Thank you very much.